Here we are again. So, and this is a really nice introductory problem that we definitely could do using geometry here. We can calculate distances. I can calculate this distance here based on this, based on this, based on the angle. But basically, the problem is asking you to determine the length of the rod AB, and the part that we have to apply from this course in order to do that is just basically finding the coordinates of this point, finding the coordinates of this point, and finding what is called a position vector. So we can find the position vector AB. Position vector AB. Once again, you already went through the lecture of position vector, and you should know what a position vector is. But position vector is just a vector that gives you the spatial representation of one point with respect to a different point. So you need one point, in this case the position vector AB, which is called RAB, it will give you the direction or the location of the point B with respect to the point A. That's what the position vector do. And once you have that position vector as a vector, you just take the magnitude of that, and that will be the distance, because the magnitude of the position vector is just the distance of that line or of that force or that vector. How do we find the position vector AB? The position vector AB will be the coordinates of B, Bx, By, Bc, minus the coordinates of A, Ax, Ay, and AC. This case, everything goes in x and y. So the only thing we have to know is finding the coordinates of the points. So what are the coordinates of this point? If I make this my origin, which is already established there, I wouldn't give you that. I will just give you the figure and let you figure it out where you're going to put the origin. But it's okay. If this is the origin, so in the x direction, the point B is falling just on top of the y-axis. So the coordinates for the point B, in that case, in the x direction is 0, so it will be 0, and the y coordinate for the point B is 300 millimeters. And then I'm going to find the coordinates of the point A. The coordinates of the point A are in the x direction. X direction is this distance from here to here. And what is that distance from here to here? Well, we know this angle is 30, and we know this distance is 150. And because this is adjacent to the angle, that coordinate in x will be 150 cosine 30. But remember, it's to the left of the origin, so it's going to be negative. And in the y direction, that will be the coordinate from here to here. And this is 150, and this is 30, and this is the coordinate, the distance, and the angle 30 is this one, and it's opposite to the 30. That means that we have to use the sign. Also remember, it's below the axis, so that's going to be negative 150, but sine 30 in this case. And there you go, coordinates of A minus coordinates of B. So the position vector AB will be this 0 minus this, that will be 150 cosine 30. That's 129.9 in the I direction. And now 300 minus 100 minus, no, 300 minus is 300 plus 150 sine 30. And that's 375 J. Of course, in millimeters. This is as a Cartesian vector. If I need the distance AB, the distance AB is just going to be the magnitude of the position vector AB, and it's calculated in the same way that we calculated magnitudes before, 1.2 29.9 square plus 375 square millimeters, and the distance AB will be 129 375 square plus 129.9 square root of that elevated to the point 5, that will be 396.86 millimeters. Just a simple application to show how to calculate the position vector and what to do, for example, with the position vector. Thank you for watching. See you in the next video, or better say, you will see me in the next video. Bye, guys.